Hello everyone, this is Siddiqur Rahman and welcome to the first lecture of the 7th week. So let's start with the learning objective. By the end of this lecture, you guys will able to know about the overview of sequential logic circuits, and in the next slide, you guys will get an idea what kind of topics are covered by this lecture. So let's start with the outline in the next slide. This slide represents the overall scenario of this lecture, or you can say the name of the topics which are gonna covered by this lecture, such as general overview about this lecture. After this, you will get an idea, or you will get an overview about clock signals in sequential logic circuits. After this, you guys will get an idea about sequential logic circuit along with its block diagram, example, and its classification. After that, you guys will get an idea about asynchronous sequential circuit, and after this you guys will get an idea about synchronous sequential circuit, and so on. So let's start with the general overview of this lecture. This slide represents the general overview of this lecture. So let's start. A sequential logic circuit is a form of the binary circuit. Its design employs one or more inputs and one or more outputs, whose states are related to some definite rules that depend on previous states. Both the inputs and outputs can reach either of the two states, logic 0, which is equivalent to low, or logic 1, which is equivalent to high. In these circuits, their output depends not only on the combination of the logic states at its inputs, but moreover on the logic states that existed previously. In other words, their output, their means sequential logic circuits output depends on a sequence of the events occurring at the circuit inputs, such as sequential logic circuits include clocks, flip-flops, bistables, counters, memories, and registers. The actions of the circuits depend on the range of basic sub-circuits. Now, a question may arise in your mind from the previous slide, which is what is clock? So let's start with the clock signals from the next slide. This slide represents a general overview of clock signals in sequential circuit. So let's start. The clock signal plays a crucial role in sequential circuits. A clock is a signal which oscillates between logic level 0 and logic level 1 repeatedly. Square wave with constant frequency is the most common form of clock signal. A clock signal has edges. These are the instants at which the clock changes from 0 to 1, or a positive edge, or from 1 to 0, a negative stage. Sorry, I repeat it again, a negative edge. Well, figure 1 represents the concept of clock signal, and you guys will find from the figure in x-axis there is a element which is symbolized or which is designated by time, and in y-axis there are two numbers, one is 0 and another one is 1, which is already symbolized one. When we go to 0 to 1, in that case we are going to a positive edge. If we going to 1 to 0, in that case we are going to negative to age. And in here you may find an alphabet T, which is represents the time period. So let's move into the next slide. Clock signals control the outputs of the sequential circuit. That is, it determines when and how the memory elements change their outputs. If a sequential circuit is not having any clock signal as input, the output of the circuit will change randomly, so that they cannot retain their state till the next input signal arrives. But sequential circuits with clock input will retain its state till the next clock edge occurs. From this slide, we will learn a overview, or you can say an general overview of sequential logic circuit. So let's start. Sequential logic circuits are those whose output depends not only on the present value of the input but also on previous values of the input signal, which means history of values, which is in contrast to combinational circuits where output depends only on the present values of the input at any instant of time. Sequential circuit can be considered as combinational circuit with feedback circuit. Sequential circuit uses a memory element like flip-flops as feedback circuit in order to store past values. Unlike combinational logic circuits that change state depending upon the actual signals being applied to their inputs at that time, sequential logic circuits have some form of inherent memory built in. This means that sequential logic circuits are able to take into account their previous input state as well as those actually present. A sort of before and after effect is involved with sequential circuits. In other words, the output state of a sequential logic circuit is a function of the following three states. Number one is the present input, second one is the past input, and last one is the past output. Well, sequential logic circuits remember these conditions and stay fixed in their current state until the next clock signal changes one of the states, giving sequential logic circuits memory. Sequential logic circuits are generally termed as two-state or bistable devices, which can have their output or outputs set in one of two basic states, a logic level 1 or a logic level 0, and will remain latched, which means hence the name latch, indefinite, I repeat it again, indefinitely in this current state or condition until some other input trigger, pulse or signal is applied, which will cause the bistable to change its state once again. Time has come to learn the block diagram of sequential logic circuit. So let's start. Sequential logic circuit are used to construct finite state machines, which are basic building block in all digital circuitry and also in memory circuits. The block diagram of a sequential logic is shown below. Well, as I said that this slide represents the block diagram of sequential logic circuit, but for your understanding, I have attached two block diagrams side by side. One is symbolized or one is designated by A and another one is designated by B. A figure A represent the block diagram of combinational circuit, and which you guys will learn or already learned from the previous lectures, but you can differentiate. That's why I have attached these two figures in this slide. So figure A represents the block diagram of combinational circuit, and figure B represents the block, sorry, I repeat it again, B represents the block diagram of sequential logic circuit. And if you guys look at the figure A, look at the block diagram of combinational logic circuit, then you may find there are three sections: left section, middle section, and in the right section. You may find the number of inputs in the left section, and you may find in the, sorry, I repeat it again, you may find the number of outputs in the right section. Okay, and if you guys will look at the figure B, which is represented the block diagram of sequential logic circuits, you may find there are also three sections: left section, middle section, and right section. Upper left section, you may find there are external inputs, and upper right section, you may find there are outputs, which is also known as external outputs. And in the lower middle section, you may find a memory element, and sequential logic circuit has memory element. You guys just learned from the previous slide. I hope how memory element come, this will be the this will not be the question, because you have already learned from the previous slide that sequential logic circuit have memory element. Well, in the right side of the memory element, you may find internal inputs, and in the left side of the memory element, you may find internal outputs. And in the left side of the block diagram of sequential logic circuit, or you can say the lower left side, you may find the current state, and in the lower right side, you may find the next state. So let's move into the next slide. Well, now time has come to learn about the example of sequential logic circuit. So let's start. Generally, we come across many counters in our daily life to count the number of objects. For example, to count the number of audience entering or leaving an auditorium, or to count number of vehicles in parking. In this, when any person enters into auditorium, the counter increments its value depending on its present value. Similarly, it decrements its value depending on the previous and present value. So counter retains the present state of counter to do next operation. This is analogous to sequential circuits, which changes their state according to the previous and present signals. I hope you get an idea what does sequential logic circuits actually do. So let's move into the next slide. Well, from this slide we may learn the representation of sequential logic. So let's start. The word sequential means that things happen in a sequence, one after another. And in sequential logic circuits, the actual clock signal determines when things will happen next. Simple sequential logic circuits can be constructed from standard bistable circuits such as flip-flops, latches, and counters, and which themselves can be made by simply connecting together universal NAND gates and or NOR gates in a particular combination way to produce the required sequential circuit. figure 3 represent the representation of sequential logic, and you may find this figure has 3 sections: left section, middle section, and in right section. In the left section you may find two things: upper left section you may find input, and lower left you may find previous state. And in the middle section you may find, or you can say the lower middle section, you may find the memory element or memory section. And in the right side you may find three things. One is upper right section. On upper right section you may find the output. After that, middle of right section you may find positive feedback, and lower right section you may find the clock signal, which is conducted or which is act as a input into the memory element. So let's move into the next slide. Time has come to learn the classification of sequential logic circuit. So let's start. As standard logic gates are the building blocks of combinational circuits, bistable latches and flip-flops are the basic blocks of sequential logic circuits. Well, sequential logic circuits can be constructed to produce either simple edge triggered flip-flops or more complex sequential circuits such as storage registers, shift registers, memory devices, or counters. Either way, sequential logic circuits can be divided into the following three main categories. Number one, asynchronous or event driven, which means asynchronous circuits that change state immediately when enabled. Enabled means activated. Second one, synchronous or clock driven, which means synchronous circuits that are synchronized to a specific clock signal. And last one is pulse driven, which is a combination of the two that responds to triggering pulses. Well, this slide represents overall scenario of the classification of sequential logic circuit. As we have already just learned, the sequential logic circuit is classified into three main types. Actually, two types. One is addition, and pulse driven is actually addition. So actually two types. One is asynchronous and another one is synchronous, which is asynchronous is also known as event driven, and synchronous is known as clock driven. And after this classification we get cyclic and non-cyclic. Well, from this slide we may learn the general overview of asynchronous sequential logic circuit. So let's start. The sequential circuits which do not operate by clock signals are called or are known as asynchronous sequential circuits. These circuits will change their state immediately when there is a change in the input signal. Next, the circuit behavior is determined by signals at any instant in time and the other in which input signals change. Next, they do not operate in pulse mode. Next one, they have better performance but hard to design due to timing problems. These characteristics you need to remember. Next one, mostly we use the asynchronous circuits when we require the low power operations. And this one is also need to be remembered. Last one, they are faster than synchronous sequential circuits as they do not need to wait for any clock signal. Well, time has come. I repeat it again. Time has come to learn the block diagram of asynchronous sequential circuits. And we just have learned from the previous slide that this type of sequential circuit don't need clock signal. And if you look at the block diagram of asynchronous sequential circuit, that then or that you can find there is no clock signal into the memory element. So that's why this type of sequential circuit are faster than other type of sequential circuit. And in this block diagram you may find three sections. One is left section, second one is middle section, and last one is right section. In the left section you may find, or you can say the upper left section, you may find the number of inputs, and the lower middle section you may find the memory section, and in the right section, or you can say the upper right section, you may find the number of inputs. So that's all from the block diagram of the asynchronous sequential circuit. Well, there are some application of asynchronous, I repeat it again, there are some applications of asynchronous sequential circuits, and which is represented in this slide. And so let's start. These are used when speed of operation is important. Remember these things. As they are independent of internal clock pulse, they are operate quickly. So they are used in quick response circuits. Well, these type of circuits are used in communication between two units having their own independent clocks. Next, this type of circuit are used when we require the better external input handling. Though asynchronous sequential circuit has applications, but this type of sequential circuits have some limitations also. So let's start. There are some limitations of asynchronous sequential circuits, such as number one, asynchronous sequential circuits are more difficult to design. Next one, though they have a faster performance, but their output is uncertain. Well, time has come to learn another type of sequential circuit, which is synchronous sequential circuit. So this slide represents the general overview of synchronous sequential circuits. So let's start. In sequential, I repeat it again. In synchronous sequential circuit, the output depends on present and previous states of the inputs at the clocked instances. The circuits use a memory element to store the previous state. The memory elements in these circuits will have clocks. All these clock signals are driven by the same clock signal. Well, this type of sequential circuit has some characteristics. So let's start with the characteristic of synchronous sequential logic circuit. Number one, using clock signal, state changes will occur across all storage elements. Next one, these circuits are a bit slower compared to asynchronous sequential circuit because they wait for the next clock pulse to arrive to perform the next operation. Next, these circuits can be clocked or pulsed. Next one, the synchronous sequential circuits that use clock pulses in their inputs are known or are called clocked sequential circuits, and they are very stable. Next one, the sequential circuits that change their state using the pulse, and these are called pulsed or unclocked sequential circuits. Now we need to, or we will learn from the next slide the block diagram of synchronous sequential logic circuit. So let's move into the next slide. Well, as we have already told that this slide represents the block diagram of synchronous sequential circuits. So figure 5 actually represents the block diagram of synchronous sequential circuits, and in this block diagram we may find three sections. One is a left section, another one is a middle section, and another one is or last one is output section, right section. In the left section, or you can say in the upper right section, you may find there are number of inputs, and in the lower portion of the middle section, you may find there are two things. One is memory element or memory section, and which is connected to AND gate as well as clock signals. Okay, that's why we said in the lower middle section you may find two things. One is memory section and the inputs of the memory section, which is two input AND gates as well as clock pulse. And in the upper right section you may find the number of outputs. So that's all from the block diagram of synchronous sequential circuits. So let's move into the next slide. Well, from this slide we will learn, or we get some idea about the application of synchronous sequential circuit. So let's start. There are some applications of synchronous sequential circuit, such as used in the design of Moore Millet state management machines. They are used in synchronous counters, flip-flops, etc. In the next slide, we will learn some of the limitations of synchronous sequential logic circuit. So let's move into the next slide. Well, there are some limitations of synchronous sequential circuits, such as all the flip-flops in synchronous sequential circuits must be connected to clock signal. Well, clock signals are very high frequency signals, and clock distribution consumes and dissipated a large amount of heat. Next one, critical path or the slowest path determines the maximum possible clock frequency, hence they are slower than asynchronous circuits. Well, time has come to learn the applications of sequential logic circuit, or you can say sequential circuit. So let's start. As the definition of the sequential circuit itself defines that these operate on the memory elements, the major application of these circuits is to build up the memory unit from a small memory card to a huge computer memory. The application of the sequential circuit must be there. Well, these extensive applications of sequential logic circuits are shift registers, flip-flops, analog to digital and digital to analog converters, counters, clocks. It can be used as registers inside microprocessors and controllers to store temporary information. And last one is applied in programmable devices such as complex programmable logic device, which is in short CPLD, programmable logic device, which is also known as PLD, and last one is field programmable gate array, which is also known as FPGA. Well, a question may arise in your mind, I repeat it again. A question may arise in your mind why we need the sequential logic circuit. So here is your answer. So let's start. Well, nowadays, digital electronics observed widespread progression and of the numerous elements. The one that received extensive prominence is sequential circuits. These sequential circuits stand as fundamental building blocks. We need these circuits to gain improved performance, and they are employed in the operations that work with less power. Well, moreover, the speed of the operation in processing the activities also gained the sight of many. Well, if we summary the last few slides of synchronous, sorry, I repeat again. If we summarize the last few slides of sequential logic circuits, then we may find in this output, then we may find the following things, such as in this output depends upon present as well as past input. Next one, speed is slow. Next one, it is designed tough as compared to combinational circuits. Next, there exists a feedback path between input and output. This is time dependent. Elementary building blocks such as flip-flops, mainly used for storing data. Sequential circuits have capability to store any state or to retain earlier state. As sequential circuits are clock dependent, they need triggering. Next, these circuits have memory element. It is not use, sorry, I repeat it again, it is not easy to use and handle. Well, an important comparison we need to learn, which is difference between combinational circuit and sequential circuit. So let's start. The circuit whose output at any immediate time depends only on the input present at that instant only is known as a combinational circuit. On the other hand, the circuit whose output at any immediate time depends not only on the input present but also on the past output is known as sequential circuit. Next one, the output depends only upon the present input and there is no need for feedback for input and output. So memory element is not required for combinational circuits. On the other hand, the output depends upon both present input and present state inside of the parenthesis previous output. So memory element is required to save the feedback state. Next one, clock signals are not required for the combinational circuits and it is not dependent on time. On the other hand, clock signals are required for the sequential circuits and it is dependent on time and clock, so need triggering. Next one, combinational circuits are faster. On the other hand, sequential circuits a bit slower if we compare with conventional circuit. Well, next, these are easy to design, which is combinational circuit, but sequential circuits are difficult to design. Well, elementary building blocks are only logic gates for combinational circuits, but elementary blocks, I repeat it again, elementary building blocks are flip-flops for sequential circuits. Next, combinational circuits is implemented in half-adder circuit, full-adder circuit, multiplexer, demultiplexer, decoder, and encoder. On the other hand, sequential circuits can be found in RAM, registers, counters, and other state-remaining machines. Well, in the next lecture, you guys will learn or you guys will know about latch. Thank you guys for your attention, and that's all for this lecture. See you guys in the next lecture. Till then, thank you.